The final lesson in Chapter 13 is 13.4, Unit Circle Introduction. We're going to take what we know about rotating into any of the four quadrants with specific angle measures. So it doesn't have to just be an ordered pair, and it doesn't have to just be a random angle rotation. We're going to look specifically at the angles below. In geometry, we had special right triangle rules. We had a right triangle with a 30, 60, 90 configuration and a right triangle with 45, 45, 90 configurations. In a 45, 45, 90 triangle, that would be isosceles, which means two of the three sides are the same. The hypotenuse is always the square root 2 times greater than either of the given sides. In a 30, 60, 90 triangle, since all three angles are different, all three sides are different. And the configuration is 1, square root 3, and 2. Now for our purposes, we're going to be focusing on those angle measures in sine, cosine, and tangent. At 30 degrees, which is the same as pi over 6, sine is always defined as 1/2, cosine would be square root 3 over 2, tangent is a little bit trickier, it's square root 3 over 3. If we do tangent of 30 degrees, that would be opposite over adjacent, and the square root 3 would be in the denominator, and we'd have to rationalize. Over at the other triangle, 45 degrees, which in radians is pi over 4, both sine and cosine are the same. The opposite over hypotenuse and adjacent over hypotenuse definitions would both be square root 2 over 2. Tangent for this one is opposite over adjacent, which equals 1. Last but not least, 60 degrees, and its radian counterpart is pi over 3. This time, sine and cosine are flip-flopped from the 30-degree answers. Notice sine is square root 3 over 2, cosine would be 1/2, and then tangent would be square root 3 over 1, which just equals square root 3. We're going to utilize these specific measures for sine, cosine, and tangent in all four quadrants, creating what's called the unit circle. When we think about how we define sine and cosine on the unit circle, remember from 13.3, the x value is related to the cosine function, and the y value is related to the sine function. This means any ordered pair can be found on the unit circle using the cosine and sine definition at that angle location. And this is true because on the unit circle, the radius is always equal to 1 unit. What we can do is take that 30, 45, and 60 degree location and identify them both in degree mode or in radian mode. And that's why I wrote those in that box up above. 30 degrees is the same as pi over 6, 45 is the same as pi over 4, and 60 is the same as pi over 3. It says label quadrant 1 in degrees and radians. Let's do that down below. Any measure always starts on the right-hand side of the x-axis. And we know that that measure is going to be 0 degrees. One kind of measure up, that smallest angle, would be a 30-degree rotation. Then in the middle, that's going to be halfway between 0 and 90, which is 45 degrees. And then that bigger arc almost towards the top would be that 60-degree location. All the way at the top, we've talked about this as well, our boundary in quadrant 1 is 90 degrees. Now when we think about that radian measure, remember radians start at 0, and then at the top, that's pi over 2. So if we just go that portion of the circle up to 30 degrees, that's the pi over 6 radian measure, that portion of the total circumference. If we start at the bottom and go all the way up into the middle, that would be pi over 4 radians. And then if we keep going up to 60, that would be pi over 3 radians. And that's labeling all your values in quadrant 1 in both degree form and radian form. The final part that we're going to display on these unit circle values are the ordered pairs that would actually calculate on the coordinate system those locations. For example, at 30 degrees, x and y would be found by taking cosine at 30 for the x-coordinate, and then sine at 30 for the y-coordinate. And that would be like making an ordered pair. Notice using that chart up above, cosine at 30 degrees is square root 3 over 2. Sine at 30 degrees is 1/2. And what this tells us is the ordered pair for that point in quadrant 1. That's square root 3 over 2 and 1/2. This point on the coordinate system at 45 degrees would be square root 2 over 2, that's cosine, and also square root 2 over 2, that's sine. At 60, cosine is 1/2, sine is square root 3 over 2. Now the only parts that we're missing are on the x-axis and the y-axis. If the radius is 1 unit, then that coordinate at the bottom would be 1, 0. And then at 90 degrees over here, that point would be 0, 1. Now as you look at that, that's a lot of information. Notice everything is positive for x and y. We have a degree location, we have a radian location, and then we have that ordered pair coordinate. What we're going to do now is look at the connection from these values in quadrant 1 to the rest of the unit circle. We're asked here to fill out the rest of the unit circle. Pause the video if you would and rewrite quadrant 1. We know all of those solutions. Once you finish writing that in, press play and we'll talk about how to create the rest of the values on this unit circle. All right, now that we have everything from quadrant 1, let's start looking at quadrant 2. You'll notice from 90 degrees, we have the same kind of increment to that first location, second location, and third location, just like we did in quadrant 1. So what that means is if we take 90 degrees and we add 30 to it, we would go all the way over to 120 degrees. If we go to the middle, that's 135 degrees. All the way to that last mark in quadrant 2, that's 150 degrees. And then over on that left-hand side, we're going to have 180 degrees. To convert from degrees to radians, what we want to do is just multiply by pi over 180 and simplify. To save us a little bit of time, I'll do that for you. 120 degrees, if you think about the rotation on the circle to that part of the circumference, would be 2 pi over 3. At 135, that's 3 pi over 4. At 150, that's 5 pi over 6. And then we should all know by now that on that left-hand side, that's 1 pi of the total circumference. I'm just going to get rid of this blue here. And then the last thing we need to do is determine our ordered pairs. And the ordered pairs really have a lot of symmetry with quadrant 1. For example, take 30 degrees on that right-hand side. Notice you're counting to the right, square root 3, and then up 1/2. At 150, you're counting to the left and up the same amount, but in quadrant 2, remember x is negative. The only change then in this ordered pair is that x is going to be negative square root 3 over 2, but then we still count up to that 1/2. So this has symmetry from quadrant 1. In the middle, 135 also has symmetry with 45 degrees. Although in quadrant 2, the x-coordinate will be negative. Negative square root 2 over 2, positive square root 2 over 2. And then 120, you guessed it, has symmetry with 60. We go 1/2 to the left, making that negative, and then up square root 3 over 2. Now the only point we have left is right on that left-hand side. On the unit circle, if we just go to the edge on that left-hand side, our ordered pair will be negative 1, 0. All right, halfway there. Let's see if we can fill out quadrants 3 and 4. If we follow the idea of adding 30, 45, and 60 each time, we're going to end up with 210 degrees, 225 degrees, 240 degrees, and at the bottom we're at 270. Let's keep going. 300 degrees if we add 30, 315 degrees if we add 45 to the bottom, and then 330 degrees if we add 60. Going all the way around to the end, remember 0 and 360, whoops, that should be a 360 right there. 0 and 360 are coterminal. All right, radian measures. If we convert all of these to radian form, 210 degrees is 7 pi over 6, 225, 5 pi over 4, 240, 4 pi over 3, and then hopefully we all remember at the bottom, that's 3 pi over 2 in radian form. At 300 degrees, we're at 5 pi over 3, 315, 7 pi over 3. At 330, that's 11 pi over 6. And then coterminal to 0 radians would be 1 full revolution around, 2 pi radians. And last but not least, those ordered pairs. Again, whoops, I don't know where that was coming from, sorry. Thinking about that symmetry, just like we had before, could you determine the ordered pairs for the rest of the circle? Pause the video and see what you can do. Think about how we went from quadrant 1 to quadrant 2. What do you know about X and Y in quadrant 3? What do you know about X and Y in quadrant 4? See if you can determine these ordered pairs. Then press play and we'll finish the lesson. Let's see how you did. Notice in quadrant 3, we have the same ordered pair sets at 210 that was 150 and 30, only both X and Y are negative. Negative square root 3 over 2, negative 1/2. At 225, which is the same as 5 pi over 4, that matches with quadrant 2 and 1 right in the middle at 45 and 135. Both square root 2 over 2, but in quadrant 3, they're both negative. And then at 240, that matches with 120 and 60, but they're both negative, to be negative 1/2, and then negative square root 3 over 2. Don't forget the bottom. Make sure you define that coordinate 0, negative 1. And then over in quadrant 4, X is positive, Y is negative, and we have 1/2, negative square root 3 over 2, square root 2 over 2, negative square root 2 over 2, and last but not least, square root 3 over 2 at 330 degrees, negative 1/2. And that's it. That's the unit circle. Individually, it looks like the quadrants have a lot going on, and they do, but notice the symmetry within this, and notice that it's not really as much as it seems. Maybe the radians get a little tricky, but there's a lot of consistency with the ordered pairs. We're not going to memorize it this year, but be prepared for next year, whether you take honors functions in trig or regular functions in trig. So get to know this unit circle. The values that we utilize here are pretty consistent in our work that we do next year in trigonometry. And this is where we'll end the video today. We'll do more with this lesson tomorrow.